So here we're going to have a look at calculating the area underneath curves or even between curves. And this is where the definite integral stuff we did in the last video is going to be really important. So if I take a look at just like a quadratic, so it might be a quadratic that looks something like this, okay, and it's got a root here at 1 and a root here at 4. And I'm asked to calculate this area between the curve and the x-axis. Well, this is where the definite integral stuff is really important, because that area is just equal to, let's say this curve is got the equation f of x, okay, so it's just that's my function of x, that models that quadratic. Then if I want to calculate that area in red, then that area is equal to the integral and the definite integral from my lower bound 1 to my upper bound 4, and I would just integrate whatever that f of x function is with respect to the variable x. And that would give me the area that's shaded there in red between that curve and the x-axis. Similarly, if I had a curve that did something like this, and it might come up like that and then down and then through, and this one, we'll draw that again. So it comes down and through like that, and this is going to be g of x. And this one has roots here at -1 and here at 0 and here at, let's say, 3. And I wanted to calculate the area bound between this curve and the x-axis. So this area is shaded, and I also want this area shaded here. Well, what I've got to be really mindful of is that I don't just integrate g of x from -1 to 3. We can't do that, and the reason being is because if you would have integrated this quadratic that we did just before, you would find out that the area that you get is actually a negative number. Now, of course, negative area kind of doesn't make sense, so we would just convert that to a positive. So when you actually did this definite integral up here, you would get a negative number, but then when you report the area that you get, you would give it as a positive number. So what we would see kind of happen is if I just integrated from -1 to 3, I would see this positive area actually start to cancel out this negative area in this calculation, which we don't want. So we're going to get an answer close to 0 if I just went from -1 to 3. What I need to do is I need to split this integral up. So I would need to go from -1 to 0 and calculate that positive area first. So I would do that. And then I would take that number, and then I would look at the area from 0 to 3, which is going to be a negative number. I would make sure all of my numbers are positive, and then I would add those two areas together. So just be very mindful of that positive and negative area can happen. Let's apply this in an example. So we'll come down here. Let's say that we do f of x is equal to -3x squared plus 9x. And I want to find out what the area is between, so the area between f of x and the x-axis. So let's get a little bit of an idea on what this curve might look like. Well, it's a quadratic, so we know that quadratics are either happy face or sad face. And we know from the negative out the front that it's going to be a sad face quadratic. So can we get some roots? Because if I can get the roots, remember that's going to help me define the bounds of my definite integral. It'll mean, if I have a root at 0 and then a root at 2, I would do my definite integral from 0 to 2. So remember, my roots are when my function is equal to 0. So in other words, when -3x squared plus 9x is equal to 0. Now if I factorize this and I bring out a -3x out the front, I'm just left with x minus 3. And therefore, here I either get that x is 0, or here I get that x needs to be 3. So I've got two roots. I've got a root at 0, 0 at the origin, or I have a root at 3, 0. So what that would look like graphically, this is my Cartesian plane. If I was to plot this quadratic, I have a root here at the origin and a root here at 3, and I'm going to do something like this because we know it's a sad face. So the area that I'm looking for is this area here. Now, I've only got one area to deal with, it's just the positive area, so I don't have to worry about splitting my integral up. So I quite simply, if I want to calculate what this area is, I just integrate from 0 to 3, and I integrate my function, -3x squared plus 9x. So I integrate that, I would get a negative x cubed plus 9x squared on 2. So you can check that, just adding 1 to the power, dividing by the new power, and we do that from 0 to 3. So we just come down here and we crunch this definite integral like we've been doing lots of practice on now. So we just bring that 3 in. So negative 3 cubed plus 9 times 3 squared is just going to be 81 divided by 2. Subtract, well, when I put my 0 in, I'm just going to get zeros. So I just subtract 0. Nothing happens there. So here I have negative 27 plus 81 on 2, which if I continue to simplify this down, negative 27, well, that's just negative 54 over 2 plus 81 over 2, which just gives me 27 over 2, or 13.5 square units. So the answer here for this area in the red would be 13.5 units squared. So all we've done is we've worked out where our roots are, because that helps us set what our definite integral bounds are going to be, and then we just do this definite integral and we're able to calculate that area bound between that curve and the x-axis. Let's do another example. So let's come down here, and this time we might have something like f of x is equal to negative x cubed plus x. And again, we want to find the area bound between this curve and the x-axis. So first of all, let's see if we can find some roots, because that's going to help us give us a little bit of an idea on what's going on in this graph, as well as find those bounds for that definite integral that we want to calculate. So the roots are when this function is 0, or when negative x cubed plus x is equal to 0. So here, if I just add x cubed to both sides, I'm trying to find out when x is equal to x cubed. Now that can happen 3 times. That can happen when x is 0, that can happen when x is 1, and that can happen when x is minus 1. And so I've got 3 roots. So if I look at my Cartesian plane, I've got a root down here at minus 1, I've got a root at 0, and I've got a root at positive 1. Now, if I want to think about what could be happening here, it could either be going like this, or it could be going something like this. Now, look, we could work that out pretty quickly and easily which one it's going to be as I make x really, really, really positive. So up here, when x gets really, really, really large, this term takes priority and I start to go really, really, really negative. So this one here would be the correct graph. It's not overly important, because when you do the definite integrals, you're going to get told which one of these it is anyway, based off which one gives you the positive area and which one gives you the negative area. But it's a good skill to be able to pick which one it is that which situation we've got here. So this is at 1, this is at 0, and this is minus 1, 0, and 1. So I'm going to need to split this integral up, because here I've got negative area and here I've got positive area. So I can't just integrate from minus 1 to 1. So I need to integrate from minus 1 to 0. And then I'm also going to integrate from 0 to 1. And I'm going to see what I get. Let's see if our prediction on which graph it was is correct. So when I integrate this, I'm integrating negative x to the power of 4 over 4 plus x squared over 2 minus 1 to 0. Now when I put 0 in, I just get 0. Subtract when I put minus 1 in. So I get negative 1 to the power of 4 is just 1 over 4, so I get negative a quarter, and here I get positive a half. So negative a quarter plus a half is just 1 quarter, and then I've got the negative out the front, so I get negative 1 quarter here. So look, you can check that, but what that's telling me, the fact that this is negative, is that from negative 1 to 0, so this area here, that's the one that sits below the x-axis, so that's the negative area. So our prediction was correct. It couldn't be this one, because this area over here is most definitely not negative. Let's do the same from 0 to 1, so this time we're calculating this side. Well, I get my same integral, negative x to the power of 4 on 4, plus x squared on 2, and I do this from 0 to 1 this time, sorry. And well, I get negative a quarter plus a half, subtract, and then when I put the 0 in, I just get nothing. And well, this one here is just positive a quarter. So I've got negative a quarter area, which is referring to this area here, and I've got positive a quarter area, which is referring to that area there. So my total area is 2 quarters, which is just a half units squared. Now, if you hadn't split this integral and you just integrated from -1 to 1, you would be adding minus a quarter to positive a quarter, and you would have got 0, which we know isn't true. There is area there. So you've got to make sure you split that integral up.